All right, we're going to make a shift now and leave conversions of measurement and talk about calculations in geometry. And this lesson is about calculating area. You should have a handout that has formulas, and if this were an online class, then these handouts would be available under a button that says handouts. All right, for each one of these, I'm going to use a formula to find an area, if that's what it's talking about. Two things to start with. Know what you're supposed to measure, area. Know what kind of shape it is. So I know that you recognize this is a rectangle. So once you know you're looking for area and you know what the shape is, you write down the formula. Area is base times height. For this one, it is 13 meters times 6 meters. Keeping my calculator handy to do this arithmetic. I have 13 times 6. I have 78. Now this is kind of important. Not so important in my math lab, but it will be important on your test. Meters times meters gives you square meters. Area is measured in square units. How many little squares would it take to cover a particular shape? So in my math lab, you see that the units are already there. They're not there on the test. They're not there on the review. You will be penalized if you leave them off. Okay? Number 2, we're supposed to find the area. What's the shape? It's a square. Now you can use the rectangle's formula for a square because a square is a rectangle, but it has its own formula. It is the side squared. So it is, and I'm going to use parentheses, 8 inches squared. 8 times 8 is 64. Inches times inches is inches squared. Done. Square inches. All right, number 3. And I know that tons of this is review, and I hope it is. I hope it is review. All right, I'm supposed to find area. What's the shape? What is that guy? It's a parallelogram. A parallelogram, by definition, is a 4-sided figure, and it has 2 pairs of opposite parallel sides. So these are parallel, and these are parallel. If they're not, then it might be a different figure. The area formula is the same as that for a rectangle, because a rectangle is a parallelogram, base times height. So it is 51 centimeters times 47. Whoops. What is the height of this parallelogram? It is 42. The base can either be down here or up here. The height must be the perpendicular distance between those two. So this is the height. Why did 47 get printed? To distract you, to try to tempt you into using it when you shouldn't, or maybe even to tempt you into finding the perimeter. So 42 centimeters, so you might make a note about that. The height must be perpendicular. So 51 times 42 gives me 2,142 centimeters squared. All right, number 4. I'm still supposed to find area. What's the shape? Triangle. One of the reasons that they might put numbers on here you don't need is If it had said perimeter over here instead of area, you would add the lengths of the three sides. So it's checking to see, are you reading to do what's asked? All right, area is, on your sheet, it says 1/2 base times height, because a triangle actually would be considered half of a parallelogram. I use a slightly different version. It's more calculator friendly. I use 0.5 times base times height. And you are welcome to change it on your handout if you want to. For triangle, where it has 1/2 base height, if you want to write this beside it, you can. Or maybe you don't need the reminder. So it is 0.5. The base of the triangle is 17 inches. What's the height of the triangle? 10 inches. It has to be perpendicular to the base. The height must be perpendicular to the base. So I'm going to multiply 0.5 times 17 times 10, and I get 85. And what are the units? Inches square or square inches. All right, number 5. It's another triangle. This, by the way, is called an obtuse triangle because it has an obtuse angle in it. When it is one of those, the thing that's a little different is that the height is measured outside the triangle. What they do is they say, oh, this base, yes, I know it's 9.9 yards, but if I extended it just to have a platform, how high is it in a perpendicular manner up to the highest point? So the height is measured outside of an obtuse triangle. All right, we're finding area. It's a triangle. I'm going to use 0.5 times base times height. It's 0.5. The base of the triangle, the way I have it drawn, is 9.9 yards. The height is measured to be the perpendicular distance. It's 6.6 yards. And to the calculator, 0.5 times 9.9 times 6.6. And I get 32.67 yards squared. It says type an exact answer, so I don't need to round to any particular place. All right, number 6. This is another four-sided figure. We've had rectangles, squares, and parallelograms. This is a four-sided figure that is not a parallelogram because these two sides are not parallel. So do you know what this one's called? A trapezoid. Because there are two different bases, what you actually end up doing is taking the average of the two bases. And how would you find the average of two numbers? You would add them up and divide by 2. Well, the formula doesn't necessarily make you think about that. The formula on your sheet will be area is, because I'm finding area, 1/2 parentheses little b plus big B times the height. So you are adding the two bases and multiplying by 1/2, which is equivalent to dividing by 2. You're taking their average. I like to use 0.5 times b plus b times h. So it is 0.5 times, it doesn't care which one you call little b and which one you call big B. So I usually just say it's the top, which is 18 meters, plus the bottom, which is 27 meters. And whatever I get, I will multiply by, what's the height in this trapezoid? 8 meters. With the graphing calculator, you can type this in using the parentheses and it's perfect. If you have to use a a calculator that isn't quite so sophisticated, you need to do the order of operations. Do what's in parentheses first and then multiply the numbers. So I'll have 0.5 times, whoops, I don't need the times, I can just open parentheses, 18 plus 27, close parentheses, times 8. And I get 180. Now, what would the units be? When I add meters and meters, I'll have meters. Then when I multiply times meters, I get square meters. And that makes sense. Area is in square units. All right, the next one, there's 2 handouts you're going to want to pick up. Okay, the next one, and I put in a couple of these because this is more common than anything else. Most of the shapes that we have to find areas for are not traditional shapes. I don't have a formula for L shape. Okay, so you need to cut it. And you have a variety of ways to cut it. I'm going to choose to cut it here. Is that okay? So now I have 2 pieces and I'm very familiar with both of them. This one, it's a little rectangle. And so I'll just draw it. And it is 2 by 4. And these are meters. And I hope it doesn't bother you that I put the 4 on bottom instead of on top. The area is base times height. It is 4 meters times 2 meters. It is 8 meters squared. And you might be able to just see that and sneak in 8 meters squared right there because you know it's a 2 by 4. Now, what I wanted to talk to you about is this other rectangle. I need the base and the height. Now I've got 3 meters. That can be the base, even though it's sitting at the top. What I don't see is that length. Let me make this a little bigger for the people in class. I don't know that length right there. Do I have enough information to get that length? Okay, I do. Do you agree that this is made up of this distance, which is 6, and this distance, which is 2? And so what I usually do when I don't know the length on a shape is I compress. And it turns out that this lines up over here and this lines up over here. You will see if you look at mine on my lecture notes that I put a little dot here and I put that this is 2 meters and this is 6 meters, which means it's a total of 8 meters. Does that make sense? That measurement's not given, but there's enough information to get it. Looking over here, you can see that that one's 2 meters, this one's 6 meters for a total of 8 meters. All right, so now this, and I'll shrink it back down now. Area is base times height. It is 3 meters times 8 meters, which is 24 meters squared. It does not matter on a rectangle at all which one you call the base and which one you call the height, because you could rotate it and it would appear to be different. The area is the sum of these two. So it is 8 meters squared plus 24 meters squared, which is 32 meters squared. When you have what might be called an irregular shape, try to find some customary shapes that build it. And you can break it any way you want as long as you can recover the measurements. All right. Let's take a look at this one. It looks like, kind of like the children's version of a house drawing, or my version of a house drawing. How would you, I don't have formula on my formula sheet for house shape. How could I cut it? Okay, where, down here? Good. Well, okay, there is a way to do that. What you're proposing is, if this were closed up, you would have a whole rectangle, and then you'd have to subtract off those two little triangles, and you could do it. But you might have to have some trigonometry to do it. Okay? So, is it possible? Yes. Do I recommend it? No. Okay? So, but you're on a good track. What could you do that might be different? And I'm going to sit here and be quiet. This is called uncomfortable silence. Yes, sir. Good. Let's cut it at the roof. All right. Do I have enough information to find the area of the rectangular bottom? Yeah. I got a base. I've got a height. I've got it. We can do that much. Do I have enough information to get the area of a triangle? I need, I'll take 1/2 of the base times the height. The base of the triangle, what is it? 48. We can just copy it from down here. The height. The height of the triangle is the perpendicular distance to the highest point. Can we figure out what that is? And that is the challenge of this problem. Can you help me get the height? This distance right here. I'll go over it in a color. Good. Some people have an easier time doing that than other people do. This missing piece, this 22, this 15 and this 22 are all parallel parts, and we can do compression. What we would have, at least this is the way I see it, this is 22 meters. Up to here is 15 meters, and this part is unknown. So, like Joel said, I can take 22, the whole thing, subtract one of the pieces of 15. 22 minus 15 gives me what? 7? Obviously, I don't have mine drawn to scale, but this little piece is 7. Does that make sense to you? Because whoops. Sometimes I put my wrist on this and it moves. This 7, which is vertical, this 15, which is vertical, have to combine together to make 22. So here's my work. Area of the rectangle is base times height. It is 48 meters times 15 meters, which is 720 meters squared. That's for the rectangle. Then area of the triangle, I'm going to use the version of the formula 0.5 times base times height. 0.5, what's the base of the triangle? 48 meters. We figured out that the height of the triangle was 7 meters. So 0.5 times 48 times 7 is 168 square meters. The area of the house shape is 720 meters squared plus 168 meters squared, which gives me a total of 888 meters squared. So we got a little bit more challenging on the second one. The house was a little bit more of a challenge to break, and then we had to find a missing piece. All right. Shrinking. Number 9. What will it cost to carpet a rectangular floor measuring 27 by 9 feet if the cost of the carpet is $19.11 per square foot? Well, this is very normal. You're going to go get some carpet, and just make sure when they give you the cost per square, wait a minute. Uh-oh. I read that. I finished it on my own without reading the actual words. It is $19.11 per square yard. Oops. We didn't measure our room in square yards, did we? There are 2 ways to handle this, and I want your help in figuring that out. I have to know how many square yards are in my room, so that then I can multiply it by the $19 and whatever cents per square yard. Let me have a suggestion. Find the area first. Okay, if you look at my class notes, that's how you'll see I did it. Okay, the area is base times height. Let me get myself more room here, which is 27 feet by 9 feet, which is 243, but please notice that is square feet. They told me the price per square yard. Yesterday, did we convert units of area? If you look back, let's see if I can find mine. Look back at your handout from yesterday. And it says square units of measure, and on here it says 1 square yard equals 9 square feet. Can we do dimensional analysis? Yeah, we have to. So we have to change to square yards. So here we go. 243 feet squared over 1 times. Ooh, I need the fact. I read it. It is 1 yard squared equals 9 feet squared. That's my fact. What has to go on bottom? The 9 feet squared and the 1 yard squared on top. So I have 243 over 9. Square feet cancel. I have yards squared, and I'm hoping that's divisible. I believe it is. This is 27 square yards. Not only did I have to find the area so that then I can multiply by the cost, but I had to have it in the right units. And do you know how easy it is to overlook that? When you go to the carpet place, see how they're quoting their prices. and make sure that you measure your house in those same units, although they're going to send a professional measurer out to your house. All right, so cost. It is 27 yards squared. I want to show you something with these units. It is times $19.11 per square yard. Now, I know you probably wouldn't have worried about this, but this is really over 1. You've got some yards squared on top, you've got some yards squared on bottom. The yards cancel out, and you're just going to multiply the numbers, which probably is what you would have done anyway. So I'm doing it on my calculator, and I get a cost of $515.97, and it is in money. Can you see that this problem had a trip-up place in it? Very much so, by saying, giving you the cost in square yards. There was another route, and it didn't occur to me yesterday when I wrote up the notes, because I want to have those, I want to have done them freshly before I do them with you in here. This is the way I did it, exactly. Would it have been very hard to change 27 feet into yards? Because there's 3 feet in each yard. So you could have said that this was 9 yards. 9 times 3 is 27. How many yards is 9 feet? 3 yards. You could use dimensional analysis, but we probably didn't need to. What's 9 times 3? Isn't that the same number we just got down here? It might have been easier, but it didn't occur to me. I just thought, oh, I'm going to get the area in square feet, and I'll have to change it. Okay? All right, the next one, this is actually the number's not showing. What's the number? This is the kitchen one. This is number 10. Okay, a rectangular kitchen floor measures 11 feet by 10 feet. The stove on the floor has a rectangular base measuring 3 by 4, and the refrigerator covers a rectangular area measuring 4 by 5 feet. How many square feet of tile will be needed to cover the kitchen floor, not counting the area used by the stove and the refrigerator? I'm sorry, this is really a bad plan, and if anybody does this, they cannot come in and tile my kitchen, because I want tile under my stove and I want tile under my refrigerator. This is not a good plan, but it's an interesting math question. How would you do it? We're going to be what I would consider a little bit negligent, and we're not going to tile under our 2 appliances. So how are we going to figure it out? How much tile we need? How many square feet of tile? I'll draw you, pardon? Okay, we got, if this is the kitchen floor, and it is 11 feet by 10 feet, and its area is base times height, 11 feet by 10 feet, 111 feet squared. But money, let's just pretend we have to save every penny we can, and hey, it's just a rent house and we're leaving and we don't care. Okay, so we've got a stove sitting here, and we've got a refrigerator sitting here, and we're not going to tile under those. That means we're going to deduct that from our area. So what's the area of the stove? I'll put an S by it. Yeah, it's 3 by 4. So it's base times height. It's 3 feet by 4 feet, which is 12 feet squared. And it probably is beginning to drive you crazy that every time I mean, we all knew it was 12. And yet I wrote down the formula, I filled in the numbers, and then I did the calculation. And that's because I'm trying to leave a record of what I did, so that if you look at it later, you'll see. All right, how about the area of the refrigerator? Well, it's a rectangle. It's base times height. It is 4 by 5. 4 feet, and I keep leaving off that T, by 5 feet, which is 20 feet squared. So I know I don't need that much tile, and I don't need that much tile. How do I write it down if I want to leave a record of what I did? Pardon? Okay, what do you want me to, now if I add all these up, is that what you're telling me to do? No. Oh, okay. All right, so you're saying add these up, and that'll be my deduction, right? So if I add these two up, I get 32 feet squared. And that's got to be deducted from what I need, correct? So I have 110 feet squared minus the reduction of 32 feet squared, which is how much? I should be able to do that in my head, but I did the calculator. Oops, goodness. Okay. I don't think this is overly realistic, but we will do one in a minute that is a little bit more realistic. Let me shrink. And on this one, we might just talk through it, and I will leave you, if you want to look at it in the notes, you can, because we've still got a good bit to do. All right, it says a room is 11 by 17 feet. Got it, rectangular room. It needs to be painted. We're going to paint the ceiling. The ceiling is 8 feet above the floor. Okay. There are 2 windows in the room. Each one is 3 feet by 4 feet, and the door is 2.5 feet by 6.5 feet. Find the area of the walls and the ceiling to be painted. Okay, so the walls. What do we have going on with the walls? In fact, I'm going to draw a picture of my room. It's a bad picture. You don't want me to be your architect. All right, there's the room. Now, how many walls are there? There are 4 walls. Let's see. The room, I'm going to put the 17 and the 11 there. What's the height of the room? 8 feet? And I've been really sloppy. Those are all in feet, and I haven't put the feet on them, but they're there. All right. Walls. Do you agree that I have one wall that is, and you have to look up here to see it, that is 17 by 8? And that there is a wall on the directly behind it that is also 17 by 8. And then I have the smaller walls that are what? 11 by 8? And then I've got to do the ceiling. What are the measurements of the ceiling? Isn't the ceiling the same as the floor? 17 by 11. All right. I'm going to calculate all of those areas and I'm going to add them up because all that is supposed to be painted. And I'm just going to tell you, not do it right now, but the total is 635 feet squared. 4 walls and a ceiling. Am I going to paint the window? Am I going to paint the door? No. So, window. The window is 3 by 4, and there are 2 of them. The door is 2.5 times 6.5. Those are all things I'm not going to paint. And that total is 40.25 feet squared. How will I figure out area to paint? Won't I subtract? I will take 635 feet squared minus 40.25 feet squared. And I will get 594.75 feet squared. And you know what? That's just the first question. Scroll up. 1 gallon of paint covers 67.85 square feet. How many gallons are needed? 67.85 square feet. You know what I am changing from square feet to gallons of paint, and I can use dimensional analysis. I have 594.75 feet squared, put it over 1, multiply it by, it says 67.85 square feet, 1 gallon. 67.85 feet squared, 1 gallon. Feet squared cancel. I'm just going to do a drum roll and say that I get 8.7650 gallons. Can you go to Lowe's and ask them for 8.765? What if it was 8.2? Could you ask for 8.2? You have got to raise up to the next whole gallon. It's not a matter of rounding. If there is even a tiny bit more than 8, you got to get 9 gallons. That's not a matter of mathematical rounding. That's good common sense. Don't get less paint than you need. What if I told you that it costs $23.17 per gallon? How will you figure out the cost? I'll multiply. So I have 9 gallons. I'm going to multiply it by $23.17 per gallon. Gallons cancel. It's going to cost me $208.53. That's a huge, huge problem. As far as there's a lot of work going into that one. I need to, whoops. All right, so that was a real long problem. And the last thing we're going to look at deals with circles. We are going to find circumference of circles and area of circles. And I have taken, for this particular class, maybe not for the whole world, but I have taken number 14 out of the lesson. So it is in the lecture notes, but I've taken it off the homework set. So we just got to try to get through 12 and 13. And if we can get through 12, we can say we understand 13. All right, a circle. We have worked with different shapes. Now we're going to look at a circle. We are going to find the circumference of the circle and the area of the circle. You will need formulas, the circumference. There are two versions. I'm going to do it what I think is the easier way. I am going to say we will use 2 pi r for our circumference formula. There is one that says you can use pi d, with d being the diameter. We've got a circle, radius is here, diameter is all the way across. I'm going to use the radius because every other place in geometry when you deal with a circle, you've got to have the radius. So I say, let's just make ourselves a silly rule that says we're going to get the radius. There's my formula for circumference. Circumference is the distance around. It's like the perimeter. Circumference, you circle. The area is what it takes to cover the circle, and that is pi times the radius squared. Pi is a number that was discovered by the Greeks, and they were just so fascinated with beautiful shapes. The Greeks were known for that, and the circle was considered perfect. No start, no end. They thought it was beautiful. They discovered this relationship and they came up with this number, and when we approximate it, we will use 3.14. But we don't always approximate it, and you're going to see that in the homework. All right, the first thing says, find the circumference in terms of pi. In terms of pi means leave the pi symbol in your answer. So, let me get this stuff out of the way. Part A. Circumference is 2 pi r. In terms of pi. Now, what's the radius of this circle? Can you see it? It's 2 centimeters. Okay, so it is 2, leave the pi, times 2 centimeters. It feels awkward to leave the pi, but that's the instruction. So I will multiply these two, and I get 4 pi centimeters. That's the circumference in terms of pi. Now MATLAB, actually, let's take a look up here. I don't like this, but it's what it did. If you could see that, it says circumference in terms of pi is blank pi centimeters. You're just going to type in a 4. And they kept the pi for you. Now part B says find the circumference rounded to the nearest tenth. Now we get to use the 3.14. So circumference is 2 pi r. It is 2 times pi, which is 3.14, times the radius, which is 2 centimeters. So it is 2 times 3.14 times 2, which is 12.56 centimeters. Instructions, nearest tenth. There's the tenths. That's going to round it up. to 12.6 centimeters. And this we use 3.14. A and B are two problems. They're really the same problem, but I'm leaving the answer differently. If you want to, you can do this. If you look up here real quickly, you can take your answer to A and just multiply it by 3.14, and you'll get your answer to B. You've already found the circumference in terms of pi. Now plug in pi. The second part, C and D, says find the area. Do the same things, but find the area. Area formula is pi r squared. Leaving pi for part C. Pi times 2 centimeters squared. That's pi times 4 centimeters squared. I'm going to put the 4 in front. It's 4 pi centimeters squared. The only reason that the number in part A is the same as the number in part C is because 2 times 2 is 4, and 2 squared is also 4. These two will not normally be the same number. All right, part D. I'm still finding the area. It's pi r squared. Can I use my part C to get it? I can, or I can start over. I can say it is 3.14 times 2 centimeters squared, which is 3.14 times 4 centimeters squared, which is, and I'm just going to cheat and look, 12.56 centimeters squared, again rounded to 12.6. The only reason that the answers, the number parts of the answers are the same is because it was the number 2. Up here you're multiplying 2 times 2 because there's a 2 in the formula. Down here you're squaring 2. Either way you got 4. Could I have done 4 times 3.14 to get that? And the answer is yes. Now, this might be considered a little bit confusing. You're going to do circumference, 2 pi r. Leave it in terms of pi, and then fill in pi. Area, pi r squared. Leave it in terms of pi, then fill in pi. And there are 2 problems for you to do in your lesson. I will tell you that in the class that I'm doing this recording, you will not have to do both versions. I will tell you to use 3.14. You will not do one on the test where you leave it in terms of pi. Okay. Whoops. Let me stop this recording.